Okay, a quick announcement. Just sure. I will adjust the deadline for homework assignment number 2. I think the latest document for homework assignment number 2, I will send it to Line, okay, and also send it to the Moodle. I'll give it to the TA. So after this class, at the end of the last class, we talk about this function called dump to JSON. And I use this example. Let me repeat for this whole thing, the basic things. We look at GPS. Sorry. So let me recap what we did. This is a definition for GPS class. Dump to JSON is essentially try to convert the internal from the C++ object converted to the JSON representation. That's why I have a function called dump to JSON. In fact, I should actually change it back to the virtual one. Okay. So this function, we're going to look into the function. But before we look into the function, there is one thing I should tell you is that we're going to start to use a library called JSON value object. Okay, JSON value object is a C++ library that has been defined in a package called JSON CPP, which you should have installed if you follow an earlier class. And in order to use this library, by the way, this is kind of the structure. Historically, I want to tell you that the GPSDD inherit from another class called core. And inside core.h, let me first tell you how to use this properly because you might not have the core in your environment. So inside the core, it has 2 lines, which is one is called EE1520 common.h. One is called EE1520 exception.h. These 2 files have been included. By the way, I just updated. If you go to, where is my GitHub? Where's my GitHub? Yeah, here. If you go to this directory, EE1520 Spring 2025 project base, and inside this, we have pretty much everything. So core is here. And let me show all file. And we have been talking about the GPS.h, obviously. And we talk about label GPS, all the source code, and locatable. Locatable thing is something we're going to talk about today. And then we talk about person time record, person time GPS record. And we talk about traceable person.cpp and traceable person.h is all there. And then finally, we have the class we went to is called, where's my time GPS record? It must be capital. Sorry about that. Yeah, time location.cpp and time location.h. So all the file we have been covered in this class. And particularly, I want to show you this file called traceable person. Let me see. Where's my traceable person? Okay. If you go to traceableperson.h, it has essentially what we cover everything, including the JSON, including everything you need in homework assignment number 2, is actually under traceableperson.h. Okay, so you can think about traceableperson.h is probably a better or newer information about homework assignment number 2. Okay, for example, step 2, how should we interact with each other, things like that. So the file is there, but I want to go back to first give you some important information. Is pretty much everything is going to be derived or inherited from core.h. And inside core.h, I have this two files. One file which you need right now, which is EE1520 common.h. And the other file, which is later, we're going to talk about exception. So exception is a big part about this class. And this two file is commonly used for pretty much all the programming this quarter, this semester, when you want to deal with this base. This is important because later you're going to do this to develop your final project as well. All right, so let me go back to, then we go to what is E1520 common.h. So under E1520, you can see that I already include for you. I mean, you will have your own opportunity to examine each of the line, what it is and what it does. But I kind of include pretty much all the file that's actually commonly useful for your development. That's why I have uni std string, all kind of IO string, std IO, and a bunch of things. And also this bunch of things starting from this line, pretty much maybe from here. This is a C++ class, except that std.h, for example, IO string, IO manip, CSD standard lib, SS string, C time exception. Those are C++ standard include files. So I include a bunch of things there, and pretty much it cover everything you need. And then this is what I want to tell you is that for using JSON CPP, which you need to include this 4-line. So what I'm saying here is that if you are not using my EE1520 common.h, then which means that you might not have this 4-line. So you can manually add it to your program such that your program can compile with the JSON column value class. Okay, this 4-line, if you add this 4-line, the JSON CPP part is done. But you also need what we call JSON RPC CPP. Then you need extra line, which I usually don't include it in this file. I include that, for example, if you come to, let me see, client. Do I have this file called client? Let me take a look. What? Is that capital? Oh, that's interesting. Oh, I know what happened. This is a different directory. I will use E1520. I will say update. If I do update.cpp, you can see that I add one more line here. This is for JSON RPC CPP. If it's a client side, you have JSON RPC CPP client connector. If you go to the server side, it has this line, server connector HTTP server.h. So those include file are needed for the remote procedure call part of the program. And by the way, it's complicated. In my later application, you will see that sometimes you might have a program, they're acting as both client and the server. In that case, you need both lines in the same program, okay? We will show you some example, much more detail about JSON RPC, but right now we should focus on JSON CPP, which is you need those 4 lines for dump to JSON. Okay, having said that, let's actually come back to this program, which is let's go to gps.cpp. Let's look at dump to JSON. So assuming you already include GPS.h means that indirectly you include EE1520 common.h, which then include all the include line you need to use the JSON CPP. And that's why you can use this one, dump to JSON, which let me actually parse this view line and hopefully you see how it works. So the idea here is that I'm going to, this function dump to JSON is going to return a pointer to the JSON value object. Okay, so essentially I create a JSON value object which represent what is the C++ content of this object in the JSON format. And the way I do it, you can see the first line, I just using new to create this object, which I'm going to return. If you look at this line, it's basically create this object called result pointer, and then I basically just return. Okay, so this JSON object is dynamically allocated using the command new. New, in case you don't remember, I said that before, is an equivalent of malloc in the traditional C memory allocation, dynamic memory allocation. Okay, once you have this result pointer, what is a result pointer? The way to look at it is result pointer is a pointer to the JSON value object has been allocated in terms of memory or initialization by this particular line. Okay, now once you create a placeholder we call JSON object, now you can actually insert all the element. In this case, you can see that because it's a pointer, I have to do this way. Star result PTR, which is the object itself. And then I use operator overloading because usually when you have a bracket, it's inside the bracket must be an integer. But now because I use the operator overloading, now I can put a string. I overload that with a string. I remember I showed you an example when we talk about operator overloading, which I also did the same thing, which is overloading a bracket and then with a string. So once I have this, and what's this at latitude? This latitude is a double, which is a floating point. So essentially, I create the object that has that capability. And now I have a latitude into the latitude, longitude into the longitude. Okay, that pretty much served the purpose for me to fulfill the requirement of dump to JSON, convert a GPS object to a JSON format. Okay. By the way, later I will show you to do the other way. This way is dump to JSON is convert the C++ into JSON. And just a few lines down below, you actually see I have the other way. The other function is called JSON to object. It's essentially take a JSON object and I will convert it back to C++. Okay, so this is two-way street. I can convert C++ to JSON, and I can convert it back to C++. By the way, to have this two-way capability is so convenient for us to do a lot of things. You essentially be able to connect the two worlds. And to convert it back is your homework assignment number 3. So I'm just showing you that convert it back is a lot more complicated, and we have to use exception. Okay, we have to use, you can see that the code, I mean, when you convert it over there, is only 2 lines of code, right? Essentially 2 lines of code plus memory allocation. But to convert it back is a lot harder. I have to use a lot of exceptional handling. And in fact, you take a look at the code, it's a lot longer. And because essentially you have to check a lot of things, whether your JSON is actually following the format of a GPS DD object. But we will talk about that later, but I want you to know at this moment, we're going to do this in two-way street. Okay. All right. Any question at this moment? Okay, I'm going to tell you the next level of complexity, which means how do I do dump to JSON when you have inheritance? Okay, so let's actually take a look at another inheritance relationship, which is I call it labeled GPS.h. So remember what is a label GPS.h? By the way, label.gps.h contain all the instruction note about inheritance. You can go there and take a look. Okay, so label GPS is inheriting from the GPS DD we just saw. And the difference is that I have a one extra variable called label. Okay, so let me run the program again to see that the difference. Okay, this directory, if you do a make, it should compile everything for you and without any trouble. So one of the program we run last time is called casting. I call it EE1520 casting. Is that right? Yes. If you run E1520 casting, you actually see that this is the result of dump to JSON as label GPS because you see that has a latitude, longitude, it has a label. And if you just dump to JSON as a GPS only, then you are not going to have a label. So latitude, longitude. The reason I show you this is that, okay, the difference between dump to JSON on label GPS and the dump to JSON on GPS DD itself is the one extra key value pair, which is a label. Now I'm going to show you a trick. How do you be able to control this process to generate exactly the right kind of dump to JSON? So there is something called recursion we're going to use. So let's take a look at label GPS.cpp. So label GPS.cpp is we have to look at dump to JSON. Where's dump to, oh, here, okay. So, okay, I'm not going to use this option one. Option two is instruction, but I'm going to directly tell you, this is, I should probably get rid of all the red part. So you can do this. So there is a few instruction note, which just for your information, I put it there. But I want to tell you that if you look at the code, it's actually fairly simple. Let me get rid of the space so we can see it more in one window. Yeah, okay, this 4 lines of code. So what I want to do is I want to compare this with a GPS.cpp and compare the difference between these two. Okay, on the top was the code I showed you about 1 minute ago. And the button, let me actually try to see if I can fit everything in one page. No, I don't want to do this. Okay, I can do this. Maybe make it a little bit bigger. Okay, more or less. Okay, I'm going to show it this way. So the top is the GPS DD version of dump to JSON, and the button is the label GPS. So they have an inheritance relationship. So I'm going to leverage that inheritance relationship to implement the dump to JSON at the derived class very easily. You can see what I have here is the first line is important. is that I want to be able to represent the whole label GPS as the JSON format. So because it's a derived class from the GPS DD, so now you can see what I did here. This line I want to introduce to you is that I have this line. And just look at this line with this line. Let me just use this to help you to focus. So I'm actually compare this two lines. Okay, I'm comparing these two lines. You see that these two lines are interestingly different. The top line, GPSDD, I actually create a new JSON value object. But the line down here, I did not create. Instead, I call the function to my parent class down to JSON. So you see that I can control that. By the way, if I call this without this, let me actually show you a bug. Oh, I love this kind of experiment. I want to ask you a question. If I do this, what would happen? If I do this, okay, look at the difference between these two. So if I do this, if I just do this, okay? So I remove the GPS DD colon from this line, and I just basically call this to dump to JSON. Can someone guess what might happen? Let's try to run the program. I'm hoping the compiler will let me go through this. Okay, let me Control X, Control S, X, Control S. You can guess. Okay, I'm going to run the casting. Okay, if I run casting, you see that I got a segmentation fault. Why is that? Because I'm actually calling myself. If you take a look at this code down below here, so I'm actually inside the program of dump to JSON. Why I have this strange color? Okay, get rid of that color. Okay, so if you think about this, I'm actually inside the function of dump to JSON. And C++ allow me to call myself. And this is called recursion. So I'm just keep calling myself until I ran out the memory in the stack of my machine. Remember the memory model, I have something called stack whenever I make a function call. So whenever I ran over that limit, then the system no longer can handle that. So I'm actually getting what? Get this thing called segmentation fault. Okay, so okay, now you see that this is just take the moment to tell you that, hey, if you want to get segmentation fault, I will just write it down here. This is infinite recursion. And of course, it is going to get you a nice segmentation fault. Okay, this is going to give you a segmentation fault. That's why I have to go through this. What's the difference? Now I'm actually redirect. It's not to the dump to JSON, but instead go to the GPS DD dump to JSON, which means that I'm actually derive the call to the top part. So I'm actually calling this dump to JSON. And this dump to JSON, it will create the memory called result pointer, and it will fill in the latitude, longitude, and then gave me return the result pointer over here. So essentially, the return of this result pointer is going to be exactly the same JSON object as this one. Okay, so this is a trick about inheritance. In inheritance, not just I inherit the attribute, but I will be able to leverage that inheritance relationship to call another member of my parent class like this way. I can do this to the GPSDD to refer to that. Okay, once I've done that, so essentially I'm still dealing with the same JSON object. And then I'm going to, okay, by the way, I'm going to check. Okay, this line is a checking because I don't want to be in a situation that my, just in case, my parent class did not implement the dump to JSON properly. It doesn't allocate memory. It doesn't do certain things. So this line, I would say, is kind of my habit to be a defensive programmer. By the way, this is important in practice. What do I mean defensive programmer? As a defensive programmer, I'm using somebody else code to do inheritance. And I want to make sure that he didn't do anything inappropriately. And therefore, I want to check whether that return result is not a null pointer. If it's not a null pointer, then I basically say, if the label is not default, then I'm going to set the label to be this label, okay? And then I return the result, okay? So this example, even though it looks simple, but it has a lot of depths into that, you can actually design based on the inheritance relationship and recursively call the same member function from your parent class. And by the way, I only show you this for 2 levels. This can go over multiple levels in a very complicated case. If you look at the code, it actually call for the parents class and get to a very recursively basically extend every single C++ object and put back together exactly the right JSON format you want, and using this kind of simple thing. Okay, so that's my first lesson to you about, number one, how do you develop a dump to JSON function? And more importantly, how do you implement the dump to JSON function via inheritance, especially single inheritance? Okay, I never develop any dump to JSON over multiple inheritance. I will explain to you why later. Okay, any question about how do you develop a dump to JSON function? Okay, and by the way, for homework assignment number 2, I do want to tell you is that I already pretty much put a lot of help, a lot of hint under, wait a minute, what is this? Okay, under this directory, the project base. So what you need to do if you don't know why it is, check on your code. I mean, just for example, if I have, let's take a look at one of the code, person.cpp, because person.cpp is definitely something you will need to use. Okay, so for example, in person.cpp, let's look at dump to JSON for person.cpp. Here. So under person.cpp, I actually check whether I have the name, have a VSID as a home. If I do have that, I actually create a new JSON object. And then I basically put the name, I put the VSID, and I put the home. And then inside the home, you see that because where is the home? Home is a location. So I just say this home to the dump to JSON. I actually call the GPS DD of the home location. Okay, so you can see that whenever it's appropriate, I basically just actually put it there. Okay, and I say home is equal to this particular JSON object. So all the code is pretty much there. Please take a look when you develop homework assignment number 2. And then if you have any question, we can actually discuss. I can go over. One of the example I didn't give you in this example is that how do I include an object in the in the JSON CPP programming. For example, star JVPTR is a JSON that's actually come out of a dump to JSON from the home, which itself is an object. And in JSON, it's really, really nice is that you don't need to worry about the exact data type on the right-hand side of the assignment. By the way, this is an assignment operator, and you have a right-hand side, which is the value you're going to assign into the left-hand side, which is the placeholder for that JSON entry called home. So you don't care about what is the data type. You just put in there, and the JSON CPP library, they already take care of everything about operator overloading. And it will magically to figure out the type to convert the right-hand side. If the right-hand side is a floating point, it will put it as a floating point. If it's a string, it will put it on the string. If it's an object, it will be putting on the object. If it's an array, it will put it into the array as well. So you can see that this is very powerful when you write a program which touches anything to do with JSON using this JSON CPP library. The programmer perspective is as easy as a Python programmer, okay? Okay, this is something I want to tell you. All right. I hope you got this part. Now I want to go to the next part, okay? So now I'm going back to traceable person. I'm going back to traceable person, and let me follow the instruction note. So the number one is identify the object. And at the end, remember that I show you the example just now. Last time, we focus on the casting. I mean, the reason I talk about all this is about casting. And the casting is related to dump to JSON as well. Okay, so the next step, which is the equally critical step, is about action. So from step one, we already specify a bunch of objects as the JSON format, and we can actually define the class like a traceable person to represent what we believe that's actually useful. Okay, so now we have to look at the action part. The action part try to capture how those objects we just defined, they can interact with each other. The objects are going to be related to each other. That's why it's object-oriented programming. Object-oriented programming is not just declare individual object, but more importantly, we try to see how objects can leverage each other to accomplish the purpose. Okay, so one of the important things, now I want to tell you an example. This one is a very interesting example. This example even relevant today for our location service, such provided by Google. So what we want to do is we want to, okay, remember homework assignment number 2, what we want to do is that a person is moving along, walking from the classroom to the bus stop and get on the bus and basically get off the bus at some point. And now we want to find a way to track where this person might have been in losing his phone. So the person actually lost his phone, and how do we actually track that? Okay, so in order for you to do that, the immediate question is that you must be able to track a person's location. This is called traceable person, okay? So now I want to ask you, how do you really track the location of a person? Practically, how do we really do that? You have some idea how we can track? You want to say try something, even though I didn't have chocolate today. Okay, I still need to visit Costco. I lost my phone there. Okay, let me tell you that how you track your location today, you're actually depend on your device, right? Depend on your phone. Your phone has a GPS. Then I do not have a GPS. Okay, I do not have one. You do not have one. The reason you have GPS location is because you have at least one of the device that has a GPS. And therefore, we're assuming this device is really close to you such that you are a traceable person. So now this is interesting. Then in object-oriented design, are you going to put your location information associated with yourself? Or you should put the location information associated with your device. And then you associate yourself with the device. Let me actually tell you two options, and then you can tell me which one you think is better. So option number one, associate the GPS location with the person. And option number two, you associate GPS location with the device, such as your phone. And then you associate the phone with the person. So, okay, we do have this two options, right? We can directly associate the GPS with the person object. We associate GPS object with a person object. Or we associate GPS location with the phone object and associate the phone object with the person. So, I mean, this sounds really simple, two options, but it actually, there are two different design and it will have a interesting difference. Okay. I'm going to pull out. Oh, by the way, first, do you have any question about the different? Let me actually talk about what do I mean by association. Association means that I'm going to relate these two objects together. So let me tell you that how I can potentially relate these two objects together. So let's go to person. So if I have a person object, if I want to have a GPS location, I can actually just say, hey, by the way, this GPS home is your home address. It's not a traceable location. So I'm just giving you an example. I can put GPS DD, and then I say current location. Okay, I can do that. I associate this with a person. So you see that I'm actually binding these two objects together. One is person, and then its current location. I bind these two together. Okay, this is option number one. I'm going to block it because I just want to make sure. So this is option number one. Okay, and the other option is like option number two. I actually have something called thing. And then I say this thing is my phone. Okay, if I design it this way, then the way I retrieve my location information is different. This one, I directly can retrieve from here. And this one, I have to go with the thing, okay? So which one is better? There's no standard answer, but let's actually consider, this is the fun about object design, is that we need to decide as a programmer how we're going to associate objects with each other. Okay, so let me actually tell you, okay, if you understand what do I mean by association, back here, then I want you to answer me. Maybe I say, how many of you prefer option number 1. Nobody prefer this? How many of you prefer option number 2? Gosh, you guys need chocolate. Okay. Wei-san and Richard, remind me, I have to get chocolate before next Thursday. Okay, it's my fault. You guys didn't answer the question. Okay, I'm sorry. Deeply apologize. Okay, all right. So be serious. Okay, there are better and worse. Okay, I actually prefer option number 2 because it's more realistic. If you think about that, when we design the object, you should reflect your design. This is a very important lesson. By the way, I spent years, didn't realize this principle. When you design the object, it has to reflect to the reality about this world as much as possible. This one is not as realistic. Okay, let me tell you one reason. Your GPS is associated with person. What happened if you forgot your phone? If you have the design of the first one, you forgot to actually bring your phone. I did that all the time. My wife did that most of the time. I always track where she is. And by the way, you should track each other. I can show you that I developed lots of applications how husband and wife, they need to mutually track each other. Okay, there's a lot of joke around that as well. I'm not going to repeat. Okay, so just to show you I'm not joking, okay? Let's see, do I have this? Let me actually check. I can tell you where my wife is. That's okay, my wife won't care. Yeah, see that G? My wife is Grace Wu. And wait a minute, where she is? She is at home. Or at least her phone is at home. This is where I live. You see, this is where we are. This is where we live. And she's there. Okay, so what happened? There are so many times. Sometimes my wife just forgot to bring her phone. She is not a phone kind of person. She always forgot. And she come with me, say, okay, I will associate my location with you. So this is very important. If you go for option number 2, you solve your marriage problem in multiple ways. Because now my wife, she forgot her phone. She can associate her GPS location with her husband or with her child or one of her children. And you can actually still represent. But first one, you're actually in trouble because I kind of lost that granularity that I cannot associate myself with a device. I just know you have that, but this is unrealistic. What happened if I lost my phone? Okay, that's number 1, unrealistic. Number 2, I want to make it even more complicated. By the way, how many phones do you have? How many devices do you have? I talk about traceable device, means that it's a GPS-enabled device. I have 2. By the way, I have 2 phones. One phone is actually from my US phone. So it has everything, but it has a US number. And then I have the other phone, which is when I moved to Taiwan, I got another phone. So essentially, I have 2 devices, which means these 2 devices might not be together. And the thing is that it might not be reporting the same GPS location. So then how do you decide what is my current location? In fact, I argue in the more complicated case, a person might have multiple GPS locations at any time. So if you think about that, you have multiple phones, but I left one phone in electrical engineering department. I left one phone in US. If you from this design, you actually see me has simultaneously appear in one of the 2 locations. But that's the right thing because I'm actually assuming the person is associated with device. Then how do I decide my true location is actually the logic between the finding between the person and the phone. I can say, hey, at this moment, I'm binding to my Taiwan phone, or at this moment, I'm binding to my US phone because I went back to US to do something else. So with this design, you reflect the reality about what's going on. Then you can use this design to handle a lot of situations. With this design, you actually don't have that. Okay, so I want to give you a lesson. This is important when you do object-oriented design. You're not just solving a problem, but you see that how you can design a system, an object-oriented system that reflect the reality. And I mean, for example, Google today, they will not be able to, when you have a multiple GPS location, they will not be able to deal with this kind of association. So ready? Over. Let me give you 2 minutes because I have to show you this. So, okay, I want to tell you that homework assignment number 2, I want to tell you that we should start with something which is simple. Start with something simple but realistic. I'm actually following option 2, which simple means I'm assuming GPS phone person, but I only have one phone. I'm assuming if you can deal with one device, you can always deal with more than one device. One device per person. That's actually another trick to simplify, to get it to work, and then we can extend. Object-oriented programming language, the best feature is it's so easy to extend to the next level. Okay, so now I'm going to show you what I did. So in the traceable person, what I have, you can see I added one thing called locatable thing. It's a phone. So which means that I only have one device which is associated, and that phone is locatable. It's a thing, it's a device. I model that. So let's take a look at a locatable thing. By the way, the code is already uploaded. You can actually play around, but I want to finish this part before I. So locatable thing is inheriting from thing. So if you remember, thing doesn't have any GPS location. It just have a bunch of like a model number, description, or whatever. But locatable thing, I need GPS, so I need to include GPS.h. So you can see that I actually inherit from thing. And then inside here, I have nothing but just a location. Okay, so you see that every single class, it looks really simple. The difference between locatable thing and thing is just one line. That's a concept I want to add through inheritance relationship. And with locatable thing, now with only one location, now I actually implement how a person object is bound to your phone. And from the phone, I can bound to a particular GPS location. And then we can develop more things toward the scenario we want to do. Okay, any question? All right, I will see you on Thursday.